Hi everyone, welcome back to YouTube classes. It's Divya here with class 8 physics. So in the last class we have seen a few of our theory part. Now let us come to the question answers of that section. Now till question number 25 we have done. Come to question number 26. Write the expression for kinetic energy of a body, explaining the meaning of symbols used. So kinetic energy equation is going to be half mv square, where m is the mass and v is the speed or velocity of the body. Now question number 26. A ball of mass m is moving with a speed v. What is the kinetic energy? See in question number 27, mass and v, that symbols are given. Again you have to repeat the equation for kinetic energy, that is kinetic energy Ke is equal to half mv square. Now question number 28. Name the form of energy stored in a wound up spring of watch. So since it is a wound up spring, it is not open, it is going to have potential energy. Question number 29. Can a body possess energy when it is not in motion? Explain your answer with an example. The answer is going to be yes, a body, even though it is not in motion, can possess energy. That is due to height or rest, you are having potential energy. So, some examples are given here, one or two. You can write the examples of potential energy given in your textbook. Any one or two examples of your potential energy, you have to write it here. Now, when you come to question number 30, name the type of energy possessed by the following. Whether it is going to be a kinetic energy or potential energy, for the given cases, you have to mention it. First one is a moving cricket ball. Since it is moving, kinetic energy. Second one, a stone at rest on the top of a building. So since it is at rest, it is potential energy. A compressed spring, so due to the change in position, or it is due to the position, it is having potential energy. D, a moving bus. So moving bodies possess kinetic energy. A bullet fired from a gun, that again it is in motion, so again it is going to have kinetic energy. Then water flowing in a river, it is also moving, so kinetic energy. A stretched rubber band, so it is in the stretched state, not in the deforming state, so it is at rest, so having potential energy. Okay. Now question number 31. Give an example to show conservation of potential energy to kinetic energy when put in use. So here a stretched bow has potential energy because of its stretched position. When the stretched bow is released, potential energy changes to kinetic energy. See children, so many examples other than this for your potential energy to kinetic energy is given in your textbook. Here it is given the case of bow and arrow, case of hydroelectricity is given there. So any example you can write which you feel easy for you, right? Now question number 32. State the energy changes that occur in a watch spring while it unwinds. A wound up watch spring has potential energy stored in it due to the wound up state initially, and then when it unwinds itself, what happens? It starts moving. So potential energy will change to kinetic energy with which it moves the arms of the watch. Now question number 33. You have to give reasons for the following cases. First one, no work is done if a man is pushing against a wall. See, a work is said to be done only when there is a displacement of the object when you apply the force. So in the first case, when the man is pushing, the wall is not moving. So no work is done. Second case, hammer drives a nail into the wood only when it is lifted up and then struck. See, on lifting the hammer, potential energy stored in that hammer is striking the nail, isn't it? So that is driving the nail into the wood. A horse and a dog are running with same speed. Which one of them has more kinetic energy than other? See, compare a horse and a dog. One which is having more mass will have more kinetic energy. So automatically hose is going to have more mass than a dog. So kinetic energy of a hose will automatically more than that of a dog. A teacher moving around on the class is doing work, but a child standing and reading a book is not doing any work. See, when a child is reading the book, he is not moving, he or she is not moving from the place. That is, there is no displacement. Displacement is going to be zero, isn't it? So that in case of a child, work done will be equal to zero. But a teacher who is walking around the class, he or she is constantly changing the position, or it is having a displacement, so that it is going, he or she or the teacher is going to have a work. Understood? Okay. Now coming to the last question answer of the session, that is state the energy changes in the following while in use. See here only 3 or 4 or 5 is given. So many examples are there in your textbook. Anything can come for exam. So according to what is there in the question, we can solve it now. Electric bulb, electrical energy to light energy. Okay. Second one, electric oven, electrical energy to heat energy. A loudspeaker, electrical energy to sound energy. Microphone, again electrical energy to sound energy. Electric motor, mechanical energy to electrical energy to mechanical energy. This one is going to be electrical energy to mechanical energy. Okay. So this is all with your question answers. So your question answer part is finished by now. Make sure you complete the whole question answers in your copy properly and complete your question answers. Put proper date whenever you are writing, write neatly, and whatever figures you are going to make sure you use only pencil. Again I am repeating. Then complete your question answers by this class, so that from the next class we can start with our numericals. Okay. So this is all for today. With this I am winding up today's class. Thank you children. Take care. Bye bye.